All I do is grow, grow, grow no matter what. Got growth on my mind, I could never give up. And every time I get that sinking feeling that makes me feel stuck, I just keep trying, I just keep trying, I just keep trying, I just keep trying. All right, y'all, welcome to another math lesson with Miss J. This is 5th grade math, and we always start with a joke of the day. So I want you to grab somebody in your house, go grab your cousin, ask your grandma or even your mom or dad, what runs but doesn't get anywhere? Grab a cup of coffee. Let me think about that. What runs but doesn't get anywhere? I think I know. Hope you got this. Y'all, it's the refrigerator. The refrigerator runs but doesn't get anywhere. I thought this joke was so funny because when my mom used to say this, that refrigerator just keeps running. Okay, but literally I'm like, that refrigerator is not running. It doesn't have any feet. So it's just a figure of speech, but it's pretty funny. All right, let's get into our lesson. So grab something to write on and write with. If you have a whiteboard, that's great. If not, a piece of paper and a pencil will be just fine. All right, in today's lesson, our task will be the same for every problem. We want to reason about the product of a whole number and a decimal with hundredths. And we want to use place value, understanding, and estimation to help. That just means that before we start every multiplication problem with the standard algorithm, we'll estimate first, and that will help us to determine if our answer is reasonable. All that means is, does it make sense? Is our answer too large, or is it too small, or does it feel like it's just about right? Our estimate will help us to do that. Once we do that, we'll go ahead and use the standard algorithm to multiply and determine where we should place that decimal, because we are multiplying numbers in the hundredths place, okay, with a decimal. And I have a special surprise today. I have a new way we're going to learn to check our math or check our multiplication. It's called the Lattice Method. So after every standard algorithm, I will show you the Lattice Method. I love this method when I'm multiplying really large numbers, but you can use it if you like it, and if you don't, you can use what works best for you. So before we dive in, I want to just jog your thinking again. Remember, as we work through the standard algorithm today, we're going to be thinking a lot about the area model, okay? So I'm going to be thinking about how I decompose those numbers in my mind and what I'm really multiplying by. Okay, so that's going to help me. So let's just remember, the area model allows us to break that number apart. Okay, we break it apart and we multiply by smaller parts, and then we put it back together. And so that's why I love the area model. So keep that in mind as we're working, okay? Now, I'm going to use a new tool today that I think will be helpful to do the math. So you won't see me, but you will hear me as I work. And hopefully you're working right along with me. The first problem we're going to multiply is 2 31/100ths times 32. So let me go ahead and make a quick switch to our problem. Okay, so we're multiplying 2 31/100ths times 32. So the first thing I would like to do is I'm going to set up my estimation. So I'm going to start by estimating. So I am going to say 2 and 31/100, and we're multiplying that by 32. Now, when I'm thinking about estimates, I like to kind of imagine a number line. So my first factor here, 2 31/100ths, I can think about that as my lower limit. If I was rounding to the nearest ones place, my lower limit would be 2 and my upper limit would be 3. And I'm asking myself, is 2 31/100ths closer to 2 or 3? Well, I can see that 2 31/100ths is less than my midpoint, so I would estimate that that one is closer to 2. So when I'm estimating, that squiggly lines means approximately. I'm going to go ahead and estimate that first factor to be 2. And now I'm going to do the same thing. I'm going to think about or imagine a number line in my head, and I'm thinking, is 32 closer to 30? Or is it closer to 40? I'm going to write that here. My marker isn't working correctly, but it's a 40. So if I'm looking at that, I would say that this is closer to 30. And so what I really have in my estimate here is 2 times 30. And I know what we've been practicing and using that place value chart to help with our understanding, that 2 times 3, those are my basic facts, that's 6, okay? And I have 1 power of 10 means that 6 was multiplied by 10, that gives me 60. So as I'm thinking about my numbers and about estimations, I realize that, hey, my answer is going to have to be close to the number 60. So now let's go ahead and begin with our standard algorithm. So when we multiplying our decimal numbers, what we learned a few lessons back, or just about a week ago, is that we can think about 2 31/100ths. Instead of thinking of it as a decimal number, I'm thinking to myself, how many total hundredths is this? Well, 2 31/100ths is the same thing as 231/100ths. And the way I would get to that solution is I would just multiply 2 31/100ths by 100. So I'm going to keep that in mind as I work. So I multiply this number by 100 to help with my thinking, to manipulate the numbers so that I could change it into whole numbers, okay? So I'm just going to write hundreds here in this example to help remind myself that I'm multiplying by, my unit here is hundreds. I don't have whole numbers, I have hundreds, okay? All right, so I'm multiplying here by my hundreds, and I'm also multiplying at 231 by 32. So let's go ahead and do the standard algorithm. Now I'm thinking about the area model as I work. With the area model, I decompose my numbers based on place value. So I'm first going to multiply everything by this 2 in the ones place. 2 times 1 will give me 2. 2 times 30, that 3 is in the tens place. 2 times 30 gives me 60, so that's 6 tens. That 6 is in the tens place. 2 times 200, 2 times 200 gives me 400, so that 4 is in the hundreds place. Now I'm going to continue multiplying. Now I'm thinking about multiplying everything that's by this 3 tens, or the 30, okay? 30 times 1, that gives me 30. I'll put a 3 in the tens place and a 0 in the ones place, all right? And then I have 30 times 30, okay? That's 3 in the tens place and another 3 in the tens place. 30 times 30 will give me 900. Lastly, I'm going to multiply 30 times 200. 30 times 200 gives me 6,000. So I'm going to put my 6 here in the thousands place. Now to finish my standard algorithm, I must add up my partial products. So let's go ahead and add together. Two plus 0 gives me 2. 6 plus 3 gives me 9. 9 plus 4, that gives me 1,300. So I'm going to bundle one of those to the thousands place here, and I'm going to put my 300s remaining. Now I have 6 plus 1,000. That's going to give me 7,000. So now I'm looking at this answer, and that actually does not make any sense to me, because how in the world could my answer be 7,392 when my estimate should be 60. My answer says, my estimate's telling me that my answer should be around 60. So I must have forgotten to divide my answer by 100 again. If I remember correctly, when I started, I multiplied 2 31/100ths by 100. So to get my final answer, I've got to divide again by 100. So I'm going to divide this answer by 100. When I divide 7,392 by 100, I will end up with 73 and 92/100ths. Okay, so now that I have that answer, let's see if I can relate that to this new method I call the lattice method. Here we go. The lattice method kind of combines everything we have learned about multiplication. So in the lattice method, what we're going to do is we decompose our number based on the number of digits we have in our answer. So in this first factor, we have a 2, a 3, and a 1. That's 3 digits. So I'm going to put a 2 here, a 3 here, and a 1 here. Now I'm going to partition that into 3 equal sections. Now in my second factor, I have the number 32. So I'm going to partition that into 2 sections. I have a 3 here and a 2 here. Okay. Now, I have that 3 and that 2. What I'm going to do next is I'm going to divide that into 2 sections to separate those 2 digits. Now, the lattice means that we are going to add based on a lateral, and lateral just means like the diagonal. So my next step in setting this up is I just draw diagonals from the top, very top corner of that first box all the way down. So we're going to do that for every box. Okay. Now, once I do that, I'm ready to multiply. So I'm going to do the same thing I've been doing. I'm going to multiply each part of this factor by every part of the factor in the top. So 3 times 1 gives me 0 tens, put a 0 on the top of the lattice, and 3 ones, put a 3 in the bottom of that box. 3 times 3, it gives me 0 in the tens place and a 9 in the ones place. So I'm going to put a 9 here in the ones place. 3 times 2 gives me a 0 in the tens place and a 6 in the ones place. Now I can see that I've multiplied by every part here of 231, and now I'm going to do the same. I'm going to multiply my 2 here times every part of that 2, 3, 1. So 2 times 1, that's 0 tens, and 2 in the ones place. 2 times 3, again I put a 0 in the tens place, that's the top of the box, and a 2 times 3, a 6 in the ones place. 2 times 2, that's 0 tens, 2 times 2, and 4 ones. Now it's time for me to add up all of my partial products. So the way that we would do that is we do add along the lattice. So here's one I'm going to try to show. Here's one lattice. I'm going to add all of these here. Then I'm going to add all the numbers inside of the next lattice, all the numbers inside of the next lattice, all the numbers inside of the next lattice, and this top lattice has a 0 there, so I don't need to add that. So let's go ahead and take a look. This first bottom right here, that represents the ones place, and I have just 2 in that lattice. 6 plus 0 is 6 plus another 3. That gives me 9 in this lattice. So I can see I haven't had to bundle anything just yet. Now in the next lattice, which will traditionally represent the hundredths place, I have 0 plus 9, that's 9, plus 4 more, that's 13. So I do have more than 10. I'm going to bundle one of those to the thousands. I'm going to bundle those 10 to the thousands place by putting that 1 there and putting my 3 here. Okay? And I'm going to continue adding. I have 6 plus 1, that gives me 7. And I have 0 in that lattice. So I'm done adding. And now what I would do here is to write my final answer, I go from the top all the way down and I write those numbers in that order. I have a 7, a 3. We know that there's a decimal there because we multiplied by 100, so now we have to divide. So our final answer would be 73 and 92 hundredths. And if I look back at my estimate of 60, that makes sense. My answer is close to 60. So that is how we would use the lattice method to check our multiplication. It is a good practice to use the lattice method to check our multiplication. So now what we're going to do, and that was a little bit longer than it normally takes, but now we'll just dive into another example and move a little bit more quickly through it. So let's take a look at our next problem here. Okay. Our next problem, we're going to multiply. We're going to, again, look at those directions. We're going to estimate first. 2 31 hundredths times 221. So we can see that our first factor of 2 31 hundredths, it is the same, but now we have a new second factor of 221. And so in order for us to begin multiplying, again, we must set up our estimation, because that estimation is going to help me to think in terms of whether or not my answer is reasonable. So let's go ahead and get started on this next one. So I first have 2 and 31 hundredths. I'm going to write my number 2 and 31 hundredths first. Okay, so we have 2 31 hundredths. This time we're multiplying by 221. Now let's see what that estimate would be. I'm going to make my squiggly lines to show that I'm estimating. So I would, again, just like I did in the previous example, I would think of my number line in my head, and I'm thinking, is 2 and 31 hundredths, is that closer to 2 or to 3? And I know that 2 and 31 hundredths is closer to the number 2. And if I look at my second factor, I'm thinking the same thing. Is 221, is that closer to 200 or 300? And in this example, I know it's closer to 200. So now I'm going to go ahead and multiply this estimation using basic facts and place value understanding. 2 times 2 is 4. And I have 2 powers of 10, meaning I'm multiplying that 4 by 100. So my estimation tells me that my solution to this problem, my product, should be very close or close enough to 400. So let's now go ahead and use that standard algorithm first. So I'm going to begin by, in my mind mentally, I'm going to multiply 2 and 31 hundredths by 100 just to change that factor into a whole number, because it's much easier to multiply whole numbers than it is to multiply decimal numbers. So mentally, I've multiplied this by 100, and I must remember that at the end, I have to divide my final product by 100 to reverse what I've done, okay, in order to get back to that original 2 and 31/100ths. So now I'm going to begin by thinking again about that area model. In the area model, we decompose each part of the factor. So this is really 200 plus 30 plus 1. The second factor is really 200 plus 20 plus 1. And I'm going to multiply with that in mind. 1 times 1 gives me 1. So I place it in the ones place. 1 times 30 gives me 30. So I place that 3 to represent the 30 in the tens place. 1 times 200 gives me 200. So I place my 2 in the hundredths place. Now I'm going to move on to my next part of this factor. And that would be a 2 in the tens place. So I have 20 times 1, that gives me 2 tens, 0 ones. 20 times 30 gives me 600. So I place my 6 in the hundredths place. 20 times 200, well, that gives me 4,000. Place a 4 in the thousands place. And lastly, I'm going to go ahead and multiply by my last factor here, part of my factor, which is a 2 in the hundredths place. So this time I have 200 times 1. I'm going to place my 2 in the hundredths place, and I have 0 tens and 0 ones. I'm now multiplying 200 times 30. That's going to give me 6,000. So I'll put my 6 in the thousands place. Then I have 200 times 200. Well, that's going to give me 40,000. So I'm going to place this 4 in the 10,000s place. Now that I've multiplied all parts of my second factor by all parts of my first factor, I am ready to add up my partial products. So let's add. 1 plus zeros gives me 1. 3 plus 2, that gives me 5. 2 plus 6, that gives me 8. Plus 1 more gives me 10. So I'm going to bundle 10 of those and trade them in for 1,000. Now I have 4 plus 6 gives me 10, plus 1 more gives me 11. Going to bundle to the next place value. Now 4 plus 1 gives me 5. Now I'm looking at my answer and I'm wondering, 51,051 is not close at all to 400. So I must have forgotten to divide my final answer, my hundredths, by 100. And when I do that, I realize that my answer is actually 510 and 51/100ths. And that is a much more reasonable answer, considering my answer should be close to 400. We can see that 510 is much closer to 400 than 51,000. So now let's go ahead and quickly, let's see how the lattice method would work for this problem. I'm going to do the same thing here. Draw a rectangle, and we're going to decompose it based on the number of digits. So I have a 2, a 3, and a 1 in my first factor. Excuse me. Okay. Then I have a 2, and a 1 in my last factor. And I'm going to just draw horizontal lines to break those apart. Now I have to draw my lattice, and then I'm ready to multiply. So I draw a lattice from the top box all the way down to the bottom box for every number. Okay, Now I'm ready to multiply. So let's go ahead and multiply these quickly. I'm going to start here with this 2 in the hundredths place. 2 times 1, that's 0 tens and 2 ones. That's a 2. Let's make that look a little better. Hold on. 2 times 3, that's 0 tens and 6 ones. 2 times 2, that's 0 tens and 4 ones. I'm going to continue. Now I'm going to multiply by every digit in the top factor by 2. Again, 2 times 1, 0 tens, 2 ones. 2 times 3, 0 tens, 6 ones. 2 times 2, 0 tens. Oh, it's not 6 ones, it's 0 tens, 4 ones. Lastly, I'm going to multiply by every part in the top factor by 1. 1 times 1, 0 tens, 1 1. 1 times 3, 0 tens, 3 ones. 1 times 2, 0 tens, 2 ones. So in the lattice method, our partial product, we find it again by adding along the lattice. So I'm going to do that again. And this time I'll try to make the color of my lattice a different color. So the first lattice I'm going to add along here. The second lattice I'll add the numbers along here. Third lattice will be the numbers that are going to be added along here inside of this region. Fourth lattice, numbers that are added inside of here. And the fifth lattice is here. And you see that top lattice has 0 in it. So let's go ahead and add. I have 1 in this bottom lattice, so put a 1 here. Now I'm adding my next 2 numbers. 2 plus 3, that gives me 5. 2 plus 6, that gives me 8, plus 2 more, that gives me 10. So I'm going to bundle those tens and change them into 1,000 in the next lattice, and I put my 0 hundredths remaining. 6 plus 4 is 10, plus 1 more is 11. Again, I'm going to bundle 10 of those to the next place value by representing it here. Put a little 1 there. And then I'm going to put my 1 here, so that's 11. I'm going to add in the next lattice, 4 plus 1, that gives me 5. So I can see the top lattice has a 0, so now I just go from the top all the way down and I write my final answer in the number of those orders, in the order of those numbers: 5, 1, 0, 5, 1. And I can clearly see here that 51,000 would be too high based on my estimate. So my decimal has to show that my answer, final answer, is in the hundredths place. And that means that I have a final answer of 510 and 51 hundredths. So those are 2 examples of how to use the lattice method and also how to use the standard algorithm and reason using estimation. So I hope that those 2 examples were really helpful. We're going to finish off today's video and our time together by looking at a quick misconception. So we can see this is an example where a scholar, a 5th grader, did multiply a number to the hundredths place by a whole number. You can see that. And they did a lot of things correctly. They bundled correctly. 6 times 3 is 18. They bundled the 1 to the tens place. 8 times 3 is 24. They bundled the 2 to the hundredths place. 3 times 7 is 21, plus 2 more is 23. But the one thing I noticed is that their answer, 2,358, seems unreasonable to me. So just a reminder of how estimation can help us. If they were to estimate first, they would see that 7 they would have seen that 7 and 86 hundredths, it is closer to 8, okay? Because 7 and 86 hundredths is higher than the midpoint of 7 and 5/10, okay? And we multiply 8 times 3, we get 24. So I'm thinking my final answer should be closer to 24 and not 2,000. And if I'm thinking along those lines, I would certainly have included an answer that had a decimal point where the answer was 23 and 58 hundredths, okay? So that's just a quick reminder, scholars, parents, as you're working with your scholars, that the estimation, the idea of estimating is really, really helpful to determine if that answer is reasonable. And the biggest misconception I see when multiplying decimal numbers is that scholars will correctly multiply and they will forget to place that decimal. And it's usually because they have not estimated the product up front. I hope this was helpful. I can't wait to think with you again and do more math in our next math video. Thanks for joining.